So today we're going to spend the majority of our time, or as long as it takes, going over additional bits concerning the C programming language. And today we're going to look at dynamic memory allocation. We're also going to look at the command line, and we're also going to look at inputting characters into your program from the command line, from the keyboard, I mean. All right, so this is my virtualized instance. Okay, continue trial. Okay, so this is my virtualized instance, and you'll see I have a graphical desktop, and I'm right inside of the Gary Holness directory. You would have your own directory of your choosing, and I'm going to continue on and write a new file from scratch, a new C program, and we're going to work from that. So you'll also notice it's very responsive when you scroll, and so it might be worth the 70 some odd dollars. It's your choice. I'm not forcing you to buy parallels, but if the increased speed is important to you, it's there. All right, so let's create the file, and let's call it, see, what did I call the other one? Mem alloc.c. And the editor program, if you're curious, that I'm using is called VI. It's a very simple editor. There's quite a learning curve for it, but once you get used to it, it's really quick to use. There's also other editor programs on Ubuntu, and one's called the GNU Edit program, G Edit. And if you run it, it looks kind of like your typical editor, like Notepad, right? So let's get rid of that. Quit. Okay. So, but I like to use VI, and because it looks nicer on the screen in a class. All right, so we're going to create this new file, and as I said, this file we're going to call memalloc.c. And so as a C program, we're going to first start out with the main routine, bless you. And so we're going to say number sign include standard IO, stdio .h, right? And that should almost be automatic because minimally in any C program, you're going to want to print something. So let's write the main routine, and it returns an integer type, so int main, and it takes two arguments, int argc, which is going to be the argument count, char star star, so pointer to char, arg v. And what we'll see later on is that this char star star arg v will be a list of all the strings you specify on the command line when you run this program. So let's go ahead and open the block and close the block right away, right? Because that prevents you from having buggy code if you begin the block and terminate the block up front. Okay, so let's start out with just a simple printf. Printf, okay, this is the beginning of my program. Okay, all right, that seems reasonable. \n, right? And we terminate the command. So of course, if I have this program, I don't want to have to compile it from the command line each time, running gcc-c and gcc-o to compile it and link it. So I'm going to edit the make file, and I'm going to add entries, targets, and dependencies to the make file in order to automate the compilation of this. And with the assignment that's due, regardless of how or what IDE, if you choose to use an IDE environment to compile, to create your C code, you must hand in a make file, and that make file must run from the command line, okay, as for your assignment submission. So I'm going to edit the make file, and I'm going to add another entry here to create the executable for memalloc. So memalloc, right, with no extension, that's going to be the executable. And then I'm going to come down here, and I put that as a dependency for the default rule, right? So if I type make from the command line, hit enter, and have no other parameters specified, it's going to run the default rule. And so one of the executables it's going to now enterprise to compile a link is going to be memalloc. Okay. So then let me add a dependency here for memalloc, and I'll just put it up top. Memalloc.o, the object file, the result of compiling. That's going to be one of my targets for creating memAlloc. And then the dependency is going to depend on the C file. So memAlloc.c is the dependency. So now the command I run whenever that C file has a more recent date than the dependency memAlloc.o, I'm going to run the GNU compiler collection, GCC, compile memAlloc.c. Okay, but I'm not done yet. That's the compilation stage, but I haven't done the linking stage. So I'm going to add an entry here for memAlloc, right? That's the executable. It's going to depend on the object file, the result of compilation, memAlloc.o, and the command I execute, oops, I made a mistake here. That should be memAlloc.o. Okay, and the command I execute, tab, gcc-o, so that says link together, and the result is going to be memAlloc, and the thing it's going to paste in with the system libraries, the object it's going to paste together with system libraries to create an executable is going to be memAlloc.o. Okay, any questions about this? Make sense? Yes? Okay. So we added an entry to the make file for memAlloc. So let's save that, and let's just type make. Okay, so you notice here it runs GCC to compile memAlloc.c, and then it creates memAlloc on the link stage, GCC-o, create the target memAlloc, and it's going to paste together memAlloc.o with the system library. So it's going to do static linking, as we had discussed last time, static linking. So let me run memAlloc, right? And it's just to do a basic test of that simple print that we have. This is the beginning of my program. Okay, so we know that all the bits are in place, and we're up and running. So let's continue editing this program to demonstrate the things that we are trying to show. Okay, first, any questions about this? Make sense? Okay. So the first thing you'll notice, whenever you run certain commands, like you run GCC, you notice there's the command GCC. It's actually a program, but you have this other stuff on the command line. Those are called command line options. And how those command line options are handled, or what they do, they're fed to the program, and your program engages in different behaviors based on what those options are. Right? So in this particular case, GCC is a program, and one of the options, -C, says do the compilation only, right? Engage in that behavior, run that code, right? And so how those are handled is using those parameters for the main routine, right? And those are called command line arguments. So let's take a look at memAlloc and start with our discussion on this argc and argv. Now, when you run a program, of course, you need the name of the program. And the name of the program is that first command line argument. And remember, when you have lists of things or arrays of things in the C programming language, it's a so-called zeros-based list, meaning that you count starting at 0. So the first thing in the list is at index 0, the second thing in the list is at index 1, and so forth, right? There are other languages like MATLAB, that's a ones-based list type language. And let's take a look, and let's try printf. The number of arguments is %d, it's going to be an integer, \n, and I'm going to get it to print out the argc. Okay? So let's save that, and let's test that out. Make, and I recompile and relink my program. So now when I run memAlloc, the number of arguments is 1, right? And that one argument is the name of the program. So let's say I said memAlloc, and we say argument 2, argument 3, argument 4, argument 5. So here it is, I run memAlloc, and I specify a number of arguments on the command line. If I hit enter, the number of arguments is 5. So I have arg2, 3, and 4, and then that first argument is memAlloc, right? Any questions about this? So literally, that's what GCC is doing, and any program that you run from the command line, you have the ability to give it so-called arguments that you can use in the program to control its behavior or to alter its behavior as so desired. So let's go back to the C program and let's now access these arguments. Now that's where this char star star argv comes into place. Now you might wonder, gosh, well, we talked about char star, but what does this char star star mean? Well, we have pointer to char, right? That's a type. So we have char, which is an 8-bit quantity. It's an ASCII character. And so what that first star means, it says, I'm going to have an array of characters or pointer to character, right? That's a string. The second star says, I'm going to have an array of whatever arrives or whatever appears on my left. So we have that last star here, and I have the cursor over it. That means an array of something. And that second one means pointer to character. So I'm going to have an array of strings, right? Char star star. So we have the first asterisk here, or the right-hand asterisk star. That means pointer to. Pointer to what? A pointer to things that themselves are pointer to char. So if we were to draw this out, we would have one block of memory, and in each location, you're going to have a pointer, which is a memory address, and that's going to point to something, right? I wish I had my pen up. I would actually draw it out. Maybe I'll do that another time. So that's what we're going to use this argv. The operating system uses it. When your program is called on the command line, we can now take each one of those pieces of text specified on the command line and print them out. We can access them. So I'm going to create a local variable. It's going to be an integer, and I'm going to call it number of arguments, right? And that's going to be assigned the value of argc, right? So this is a local variable to main. I am going to capture whatever that argument count is, and I'm going to use that in a loop to iterate through each of those arguments on the command line using that argv of type char star star. Okay? Any questions? Does that make sense? All right. So let me start. And so I'm going to write a for loop. For int I starts at 0 as long as I is less than the number of arguments, right? I'm going to increment I plus plus. So that's a statement, and I'm going to close the block right away for the for loop so I don't forget it later, causing a lot of propagating errors. And I'm going to create another variable, and that other variable is going to be of type char star, and it's going to be a command line string. Command line string. And because it's a local variable, I just want to, by good measure, initialize it to null, okay? Because if I don't initialize it, it's going to take on whatever value was in the memory on the stack when the main was called, because local variables are implemented by the C runtime by pushing on the stack. And the stack exists in memory, and therefore, when you push something on the stack or space for something, if you don't initialize it, it's going to interpret that value as the type that you specified in your program, right? And that can cause a lot of problems if you don't do that. So we're going to initialize that pointer, command line string, and I'm going to use that command line string pointer by setting it to each one of those strings, those char stars that are on the command line. Okay, so let's do that. So I'm going to say command line string is going to equal argv, the ith element. So I just got done saying that when you have a pointer, you can think of it as an array of a certain type. And so I'm treating this argv as if it were an array. And when I use that square brace index, I'm saying get me the ith element of that array, and that's essentially dereferencing that pointer corresponding to a char star in the first position, in the second position, third position, and so forth. And so now that I can obtain each of the num arguments many strings in that command line, I'm going to go ahead and print it out. So printf, the argument number %d, the ith argument, is %s for string, \n, and I'm going to substitute the I index for that loop for that %d, and it's positional, so it's going to insert that variable I, its value, wherever that where that %d is, and then likewise, command line string is gonna its value is gonna be inserted wherever that where that %s is. Okay. All right. Any questions about this? argc is an array of char stars, so it's an array of strings. And argc is how the program loader for the C runtime sends those command line parameters to the programs themselves. And so you don't control what argv is. It's given to you when you run your program. Okay. All right. Any other questions? And so argc is the argument count, and argv is the argument value. C stands for count, and V stands for value. Okay. So I go through, I set some local variables, and I obtain the number of arguments from the arg count. And I didn't have to do this. I could have just said I less than argc, but I like to make it easier to read, kind of self-documenting. And it's not too expensive to have an extra local variable, unless you're in an embedded environment. And then I take this argv array and I loop through it each of the ith positions, where I goes from 0 to num arguments -1, and then I obtain that char star in that position, and then I print it out, because char star is the same as a string. Okay, so let me write that, and because I updated my C file, I'm going to run make, and I'm going to recompile this program. So let me try running memalloc with no parameters, memalloc, and you'll notice this is the beginning of my program. The number of arguments is 1, and it's a zeros-based list, so the 0th position in the array, argument number 0 is /memalloc, and that's the command itself, right? So let me run it again, and this time I'm going to say parameter 2, parameter 3, parameter 4, parameter 5, like I did before. So the number of arguments there should be 5, because memalloc is 1, param2 is 2, 3, 4, 5, and then it's going to loop through and print them out. So number of arguments is 5, argument number 0 is memalloc, and then I have 1, 2, 3, 4 is param 2, 3, 4, 5. Okay? Now imagine then, if you wrote a program that said memalloc-c file name.c, right? That's what you do for GCC to compile, right? Inside of the main entry point, or the main main function for GCC, it's looping through its argument list, the argv in the main, and if it sees this -c, it's going to call a different piece of code, right? And so here we see, if I do that for memalloc, and now, of course, in this example, I'm just printing it out. I'm not doing anything with it, but you could write a program where you have a bunch of different options on the command line that it understands, and in your code, you would just check to see what those options are, and if you find a certain option, you're just going to call a different function. Okay? All right. Any questions about that? Does that make sense? Okay. So let me go back to memalloc, and that's our demonstration of the command line. And so let's say you're writing your palindrome program. You could choose, if you wanted to input your palindrome on the command line. So you might say, okay, well, let's say if this were my palindrome program, I'd say memalloc and then redivider or something like that, which is a palindrome. And then inside you would take whatever that text is and do something with it, implement your algorithm on it. Okay, let's take a look at inputting text from the keyboard. And so inputting text from the keyboard is done, many different ways you can do it, but the two ways we're going to look at is something called Scanf and something called fscanf. So if you didn't know what those were, right, it's important to know all your resources around you. You could use the manual pages, or you could Google search. That's equally acceptable. So let me type manual page, scanf, right? And you should be getting used to using the programmer's manuals that are available to you. And so fscanf. So one of the things you'll see when you have a system call definition from a manual is you'll see the different ways that you can call these functions and the related functions, and it'll also tell you what the include file should be, the include statement should be, in order to bring in the definition of that function made available to you by the kernel services. So this one says, all right, scanf, you give it a format string, and that's what that string is called that we specify to printf. And then you give it a variable. And what scanf does, it listens to the keyboard for you to type something. And when you hit enter, it inputs that string that you've typed using the format in place, but storing that value in a pointer that you specify as the second parameter. And we'll go over that. So we need standard io.h for scanf. And fscanf. So let's take a look at that. Okay, so let me exit this terminal. All right, brought up a second terminal, and standard io.h is already included. So now let's go ahead and use this scanf. All right, so the first thing you'd want to do is you want to output a message to whoever is using your program, right? For you, of course, when you hand it in, that's going to be me. And so typically, when you do a scanf, you want to do a printf to print something, because the scanf only says, I'm going to input some text from the keyboard. It doesn't print messages. That's what printf's job is. So we'll type printf, enter some text. Okay, so I like to put a colon, and when you, because it kind of looks nice, right? You don't have to put a colon on your text. It can be any text, but it kind of, looks like it's waiting for something. That's just because it's for aesthetics. So you notice here, I did not put a \n, and that's on purpose for this printf, because if you're going to ask the user, excuse me, at the command line to input something, it looks weird for the cursor to be on a new line on the left-hand side of the screen, right? And so the practice is typically when you're going to do a printf, you don't force a new line, which is this \n, right? \n is called carriage return line feed or new line, and what it does, it takes your cursor, it advances the line in the terminal, and then puts the cursor back at the left-hand side of the screen. But we don't want to do that. We want, in this case, because we're going to ask the user for input, we want to keep the cursor right after that space character after the colon. So we're going to do a printf there with no \n. And now I need a piece of memory. I'm going to use a pointer to do that, to store this input. So let's say, we're going to have a character array. So char typed string, and we're going to have buffer size. Okay, and so I'm going to create a preprocessor directive. And you could use a variable if you want to. I like preprocessors, so you can season to taste. Number sign define buffer size. And let's just make it 1024 characters. Oops, we don't need that semicolon. So this is a preprocessor directive. And of course, the preprocessor is that first portion of the C compiler that's run. And it pays attention to these commands, number sign include, number sign define. And there are others. You can look them up. They're standard C. And it causes the preprocessor to do something. In the case of number sign include, again, the preprocessor will go ahead, find the text of standard io.h, and then paste it in the beginning of this file wherever that number sign include statement occurs. When the preprocessor sees the number sign define, it'll take all occurrences of buff size and replace it with the number 2014. It shouldn't be 2014. I meant to say 1024. Okay. All right. So we're going to print our text, and we have char type string buff size. Now, of course, this variable, this character array called typed string for the string that you typed in, is allocated on the stack because it's a local variable. And of course, we said, all right, well, if you have these local variables allocated on the stack, these things take on values associated with whatever memory just happened to be there. And so this string here, this typed string character array has garbage characters in it, right? So we want to initialize it. And how we're going to initialize it is using something called memset. Memset is, as the name sounds, it allows you to set memory to a certain value. So we're going to look at the manual pages, memset, to see what the includes we need are for this memset function, and look at the parameters and look at how it works. Okay, so memset, fill memory with a constant byte value. And so you need to include string.h as the header file in order to use memset. And the memset function, the description says, it fills the first n many bytes of the memory area pointed to by s with the constant byte c. So s is the location where you want to initialize memory values. C is the number of bytes that is the byte value that you want to fill in that memory location or set of memory locations. And this size t n is the number of bytes. Now size t you can think of as just a natural number, right? A positive integer or an unsigned quantity that's 16 bits long. So we are going to call this memset, and what memset returns a pointer to the memory area. Now, we already know what the pointer is, so we don't really care about the return value. Now, you notice here, the first parameter on memset is a void star s. So that means when you do a memset, you can give it any pointer you want. Void is like saying anything, right? Or technically the nothing type. It's not an integer, it's not a char, it's void, but it works on single byte boundaries, okay? So 1 byte at a time. So let's try this. So we're going to use string.h, and we're going to call this memset. Okay. Any questions first? All right. So let's go up here, and we're going to add to our number sign includes. We're going to include number sign include string.h. Okay. So now this will allow us to use memset. And the whole purpose for memset is to initialize this type string because it was allocated as a local variable and therefore allocated on the stack. So the first thing we're going to do before we do any kind of greeting, we're going to say memset typed string, right? An array and a pointer are the same thing, right? The array variable is nothing more than a pointer to that type. And you can treat a pointer as if the underlying memory was an array of that type, or you can declare an array and treat that like a pointer. They're interchangeable with one another. So we want to set that piece of memory referred to by that address called type string, which just happens to be a pointer to char because it's a character array. So the thing we want to write is a 0, right? We want to write nulls in every position. And the number that we want to write, we're going to call this other command called size of. And so what the size of does, we could call size of, but we know how many, but size of. No, it's not there. All right, so let me look at, I was doing something else earlier. Size of in C. Okay. You can also use, lots of manuals for it on the internet. Size of will take the size of an operand. And so here's an example of using size of, right? You include standard io.h, and it's called size of. You give it the type, or whether it's the actual name of the type in the programming language or the variable of some type, and it'll tell you how big it is, right? And so if I had a data structure that I wanted to memset, I would use size of. But in this particular case, I know that that string has buff size many characters, so I'm just going to put buff size there. Okay? All right. So buff size. And what that's doing is saying, okay, for that memory location, I identify, starting that memory location or address identified by that pointer variable or array variable typed string, I want to set buff size many characters or many bytes to this value 0. Okay? So there's my initialization. Any questions about this? Make sense? All right. So now I've done that memset, and I can now guarantee at this point in the program, when I get to the printf, to prompt you to enter some text, you know what the value is or the state is of that character array that we're calling type string. So I do that printf, and now I'm going to do the scanf. Scanf, and I'm going to scan a string, %s, and that string is going to be populated or written when I type it in the keyboard and hit enter at that memory location identified by type string. Typed string. Okay. Now, one thing I could do, right, if I wanted to, you know, um, demonstrate a point, I could say typed string position 0, which is the first position, and I say get the address of that, ampersand, right? That's saying the address of the 0th position of that array, right? That's the same as saying type string the pointer, because the pointer points to the starting location. But that's a little bit confusing. That's more to demonstrate that pointers are a real thing and how that address of operator can be used. So I have this scanf, and the scanf is going to cause the system to pause for input from the keyboard, so allow me to type in some text instead of reading it from the command line as we had before. So now I do that scanf. Inside of type string is going to be that string that I typed and hit enter for. So I'm going to print that out, printf, you typed the following, and %s. Now I'm going to have a \n because I want to return the cursor back to the left-hand side of the screen and advance to the next line. And I'm going to print out typed string, right? And typed string is going to contain those characters that I typed at the command line. Okay, so we'll test this out, but before I do that, any questions? Does that make sense? Yes, okay. So let me try that out, and I'm going to clear the screen. Let me clean up the desktop a little bit. Exit that. And I'm going to type make to run my default rule, and it compiles and links. So I'm going to type mem alloc, and I'm going to put something on the command line like, I don't know, hello there. Okay. And then I'm going to hit enter. And so now, of course, it went through the command line like before. There are 3 strings on the command line: the name of the program, the word hello, and the word there. So now it's prompting me for input. You'll notice the cursor's blinking. So it printed out enter some text, :space, and now it's waiting for my input. So I'm going to do that. Goodbye there. All right, so I'm going to type goodbye there and hit enter. And you'll notice, wait a minute, something happened, right? It only printed out goodbye. And so there is a catch, and I'll use that catch to motivate fscanf. Now the catch is when you use scanf, let's go back and look back at the manual pages for scanf, because we just looked at the function signature, but we didn't really focus on the manual page, the whole behavior description. Man scanf. Right? And this is just to point out the fact that it's really important to read the description associated with these system calls. So, of course, you include standard io.h, all right, and there's the function signature. But let's go down, so hit enter a few times, to the description. And in the manual pages, you hit return to scroll, but Q quits back to the command line. So scanf family of functions scans input according to the format. Okay. It contains some conversions, so you can take the same thing and say treat this character like an integer and do all sorts of stuff with the TypeScript. All right. So it says. Scanf function reads input for standard input stream. Okay, standard input is what is also known as your keyboard. Standard output is another name for the display. It reads for input from standard input stream. It reads from the pointer stream and blah blah blah. The scanf. Okay, there we go. Consists of sequence. Hopefully it says it here. Otherwise, I'll just say it. So as you can see, it can be pretty big. Don't do that. My wife is text messaging me while I'm in class. It's not open. That's weird. All right, so let me do this. Go to full screen. All right. Um, so let me type quick. When you do a scanf, it only inputs up to the first white space character. A white space is a space. It's an end of line, \n, or an end of file. And so what it's doing here, when I type goodbye there, well, there's a space character between goodbye and there. So scanf stops there. So what I need is something else, and that something else is fscanf. And fscanf works from a so-called stream. And a stream, as the name might seem, is a sequence of characters from some source. A sequence of characters from some source can come from the keyboard, it can come from a file, it can come from the network. And in this particular case, when we want to read an entire line of text, not just the first word or the first word terminated by white space, we want to use fscanf. And in this particular case, the stream is going to be not a file, but it's going to be the keyboard or what's called standard input or standard in. So let's try out another example, and let's continue on with that and use the fscanf alongside the scanf. So printf, enter that text again, right? And so now we're going to prompt again the user to input some text, and now we're going to call fscanf, and we're going to give it the stream, and the stream is standard std_in, standard in. And let me make sure I'm reminding myself fscanf of what the command line is. Fscanf, the stream, the format, and then we need the pointer. Okay, so fscanf. So we have the stream, which is standard input. We need the format as a string, %s, and then we need the where it's going to be stored, and we're going to store in typed string. Now, of course, you don't have to use the manual pages. You can Google search. There are tons and tons of examples and explanations. C has been around for quite a while. So this fscanf version, it will print out the result. Printf, you typed the second typing was %s \n. So the second thing you type, typed string. Okay. And now, just for good measure, between when we printed out the first string and when we did the scanf for the second string, I'm going to do a memset again because I want to zero out all that memory before I input something else new to it. So I'm going to copy that memset down here so that we are reinitializing that memory each time before we fill it with information. Okay? Any questions about this? That make sense? All right, so now, okay, that's not correct, the time. All right, so now let's test this out. So let's run mem alloc. We'll give it on the, let me clear the command line here. Make, forgot to recompile it. Mem alloc, hello there, okay. So now I get prompted, and this is the use of scanf, goodbye there. I hit enter. Oops. Enter that text again. What happened? Fscanf. Standard in. So let me go out here. Deny. Let me bring up my browser and let's look for an example of fscanf just to do a little check here. Okay. Fscanf in C or scans. Let me see what I did before. Oops. Uh-oh. I don't know what happened. Give me a moment, please. Let me reboot it, and that was weird. Fails to start. Failed to start. OSC. OSC. Probably had a kernel issue with the hypervisor. Okay, we're back up on the desktop. Let me bring up a terminal, and let's hope that it didn't wipe away those changes. Yeah, it did. Oh no, it's right there. It's still there. All right. F gets. It's F gets. That's why. All right. F gets carry. Okay. All right. Let me get my bearings again. Make vi mem alloc.c. Okay. So there's the mem set, and there is the fscanf, and it's not fscanf. It's F gets. F get string. Okay. So F gets gets the string using the format. That's the number of items to get, and the stream F gets. Let me make sure it does read in at most one less size characters from the stream and stores them into the buffer. Okay. All right. So F gets target size stream. Okay. So let's go back. So we have F gets. We have the target, which is type string. The size, no more than buff size many characters. And then, I forget what the other one was. Control Z. The target, size, and the stream. Okay, foreground. And then we have standard in. All right, there we go. We're back. Okay, so we had a little bit of technical difficulty there. I don't know why it exited like that. But anyway, so fgets is another string routine, and that gets up to a maximum number of characters, in this case buff size, because I know how big the buffer is, and it's going to get it from standard in. So let's write that, and let's make, and let's run our mem alloc function. That's right, because we have to mem alloc. Hello there. Okay, so enter some text. Goodbye there. Why is it not pausing? There's something wrong with my keyboard interface. Let me look at the practice and see what I did there. Worked fine at home. Fgets. Let's try this. Yeah, all right. This is not expected. Tested out last night at home, and it's not working the same way. All right, so anyway, so let me just continue on because I really want to get to pointers and the dynamic memory allocation, and then I'll fix this problem and go over it on Tuesday to fix up the issue with getting a whole command line worth of string. I'll certainly post it on the Slack channel before that. So let's go to memalloc.c. And the last thing we want to do is we want to allocate a pointer variable, right? So to do that, we're going to use a function or allocate memory, use a function called malloc, and that's how C handles dynamic memory allocation. So malloc for memory allocation. It uses standard library.h, stdlib.h, and the function is called malloc, and it takes a size, how many bytes do you want me to allocate, and then it returns back a pointer of type void star. So let's do that. So we also, when you run malloc, at the end of your program, when you're done using that memory, you have to free that memory, which means restore it back to usage so other programs can use it. And so the function call is called free, and it takes a single parameter, which is just the pointer variable that you allocated previously. So let's run VI, mem alloc.c. Oops, where'd it go? Oh, that's weird. Malloc.c. Yeah, there's something weird going on here. Okay, memalloc.c. All right, so let's create a pointer, and let's call that pointer char star, right? And it's going to be dynamic memory, right? We initialize it to null, and that's going to be the memory, but we're going to allocate it dynamically. So it's called dynamic mem. All right, so we're going to say, let me type string buff size. Let me go down here and let me get rid of this, and we'll cover that on Tuesday. I'll also post it on Slack. Figure out why this VM is not behaving the way it was last night. So I'm going to say dynamic mem. I think that was what it was called. Up above, dynamic mem is equal to malloc buff size. So buff size many bytes, I'm going to allocate that memory. Now, when malloc returns, it returns a void star, which is a pointer to anything. But I want to change that to a char star. So I'm going to do this so-called cast operation. It says whatever type you return from malloc, change it to something that points to a char. Okay? So now I'm going to write scan printf enter other text, and there, and I'm going to write scanf %s, and now I'm going to store what I typed the second time in dynamic mem. Okay, and then I'm going to print out other text is %s \n, and I'm going to print out dynamic mem. And then the last thing I'm going to do is I'm going to free dynamic mem. And I think I forgot the include file. So we're going to go up here. It was standard library. So I'm going to add the include, # include stdlib.h. Okay. All right. So down below, I dynamically allocate memory. I enter in, I'll prompt the user to enter in another typed thing, a number type string on the command line. I do the scanf, putting it in that location of memory that I dynamically allocated, and then I print it out. So let's compile this. Make. There we go. So let me type mem alloc, and I'll end with, okay, we have a little more time. So I don't have anything on the command line. Hello there. Just say hello. All right, so other text, goodbye. And of course I can print it out, okay? And so in the second case, when I enter other text, I'm storing that in this pointer to char, but in that case, instead of statically initialized, I've dynamically initialized it. And so I'm going to also check to see, why fgets is not working. That's very strange. It worked before. Let me try it this way. Let me compile my backup. gcc-c mem alloc.c gcc-o mem alloc dash mem alloc.o. Mem alloc. Oh, that's weird. It worked there. Let me see what I did there. Dynamic allocation. fgets buff size standard in. And include string standard lib. fgets buff size standard in. Yeah, same thing. So let's try one last time and see if we can. So let's see. So let's change the scanf to fgets. fgets standard in. Let me try to remember again. Control Z. That's what I'm doing. Buffer size stream. Buffer size and stream. Okay. All right, so let's give that a shot. Make mem alloc some text. That was scanf. Yeah, that's weird. Something else is going on with the command line. I don't know what's going on. It works in the other case. It's the same code. So why don't we just I'll fix it and I'll post on Slack. And but nonetheless, the point I'm trying to make here is that we can grab text from the command line by going through our argument list. You have to initialize memory. In this case, if it's static initialization or dynamic initialization, which I didn't do this time. Actually, I should do that. You have to initialize it. Mem set dynamic mem 0 buff size many bytes. So you have to do this initialization for any memory that you allocate, because memory is carved out of available RAM, and there was something in that memory before your program allocated it. And so how you initialize memory to values is with memset, but you have to tell it how many bytes to initialize and what to initialize it to. Then you can also type in or get input from the command line at the keyboard, and fgets should be getting the entire command line when you hit enter, but scanf only gets the first character, the first piece of text separated by white space. So let's try this one more time. We should memset. No, not there. Let's memset here. Yank. Oops. Y, and let's put it here, and we'll memset sget standard in, print other text. Let's try it one more time. So let's see. Some text. Yeah, so let me try it this way. Message. Yeah, it's not seeming to work. That's weird because it works the other way. All right, so we'll fix that. I'll do that today, and I'll post it on Slack, and then we can also fix this on Tuesday in person. Alrighty. So with that, it's 10:33. I should probably end here, and we'll pick back up hopefully with the end of chapter 2 on Tuesday. All right. I'll see you then.